Hi everyone, my name's Adam. In this problem, we're going to be finding the particular solution of the first order linear differential equation y prime plus y equal to 6 times e to the x for x greater than 0 that satisfies the initial condition y of 0 is equal to 3. So before we get started, let's start with a few things that we know. Namely, that is the general form of a first order linear differential equation can be written as y prime plus some continuous function of x, p of x, times y equals q of x, where q is some continuous function also of x. And the general solution to this, or can be found by y times e to the integral of p of x dx equals the integral of q of x times e to the integral of p of x dx, and dx downstairs, and plus some general integration constant c. So using that, we'll go ahead and get started. Okay, so first looking at the general form and looking at what we have y prime plus y. Y can be thought of as 1 times y, or namely that our p of x function is equal to 1, and this is equal to 6 times e to the x. So that is going to be our q of x function. So now looking at the general form of the solution, what we want to develop is, at least starting with the left-hand side, y times e raised to the integral of p of x dx. So what do we have there? So that's where we'll start, is with the integral, e to the integral of p of x dx. Now there's two ways that this can be done. You can simplify the integral first and then put it as the exponent of e, but if the integral is simple enough, you can kind of do both things at once. So that's how we'll do this. We'll keep this as e to the integral of p of x is just 1, and then dx, and the antiderivative of 1 with respect to x is just x. So this is equal to e to the x. Now, one little nuance to pay attention to, when we take this antiderivative in the exponent of e, we're not going to add on a general integration constant. And the reason is because we're taking this integral on both sides of this general equation, they'll end up canceling out. What do I mean by that? Well, without going through all the work with what we've done here, let's take a look over at this. When we take the integral, in general, of our p of x dx, we get e to some antiderivative, we'll call it f of x, plus some integration constant c. And note we'd have the same thing on this side of the equation. We'd have e to the f of x plus some integration constant, say c. Well, from algebra, this can be written as e to the f of x times e to the c. And that's the same thing we have on the right side, e to the f of x times e to the c. Now looking at e to the c, that's just a constant on both sides of the equation, which in the long run could just be canceled out. So the long way to do this is to add the constant. The quick way is just to ignore it, knowing it'll cancel out in the long run of our work. So we'll leave it as e to the x. Okay, so now to proceed, e to our integral of px dx is equal to e to the x. So the left-hand side of our general solution is going to look like y times e to the x. And this is equal to the integral, right, of q of x, or 6 times e to the x, times, right, e to the x dx. All right. Now to continue here, we have to evaluate this integral on the right-hand side. So this can be written as, we have the integral of 6, and e to the x times e to the x, we add the exponents. We have 6 times e to the 2x dx. So to continue evaluating that, we're going to do a simple u substitution. So we'll let u be the exponent, or u equal to 2x. Differentiate both sides with respect to x. So we get du dx is just equal to 2. And noticing the only extra, say, x term in our integral is dx, so we'll solve for dx. So we have du divided by 2 is equal to dx. And so putting this back in, so bringing the constant 6 out in front, and divided by 2, we have 6 over 2 times the integral of e to the u du, which is equal to 6 divided by 2 is 3. Antiderivative of e to the u is just e to the u, and plus our general integration constant c. Okay, so putting it all together, so we have y times e to the x is equal to 3 times e to the 2x plus c. And so what we want to do is find, or explicitly solve this for y. So we're going to divide through by e to the x, all the way through on both sides. So seeing the e to the x's will cancel on our left side, giving us just y equal to 3 e to the 2x divided by e to the x leaves us with just e to the x, and we'll write this as plus c divided by e to the x, or bring it upstairs and write it as times e to the negative x. Okay, so let's take a step back and reevaluate what we're doing. So what we have here is the general solution to the first order linear differential equation. But what we want is the particular solution satisfying y of 0 equal to 3. So that's what we're going to find next. So our particular solution satisfying y of 0 equals 3. Okay. Well, we're going to take this, and so what we have is that y of 0 is equal to 3 times e to the 0 power plus c times e to the negative 0 power. And we know that is equal to the value 3. So we're going to use this to solve for our unknown constant c here. Well, e to the 0 is just 1. E to the negative 0 is just 1. So we have that 3 plus c is equal to 3. Or subtracting 3 from both sides, this tells us that c is equal to 0. So in the end, our solution can be written as y equals 3 times e to the x plus c times e to the negative x. Well, c is just 0, so we can leave that off. So the particular solution is just y equals 3 times e to the x. Thank you very much.